Hello everyone, welcome to Compiler Design video series. In our previous video, we have already discussed about intermediate code generation. What is the role of intermediate code generation? Different intermediate forms. There are three types of intermediate representation. First one is abstract syntax tree, second is postfix notation, and third is tree address code. Abstract syntax tree is a syntax tree that depicts the natural hierarchical structure of a source program. Directed acyclic graph. DAG gives the same information but in a more compact way because common sub-expressions are eliminated. And third one is tree address code. In tree address code there are maximum 3 operands and 2 operators. Next I discuss about different forms of tree address code. There are 3 types of representation used for tree address code. First one is quadruple, second is triples, and third one is indirect triples. Example of tree address code using these 3 type of representation I have already discussed in our previous video lecture. In today's lecture I will discuss about syntax directed translation, SDT. Then first, what is syntax directed translation? Why we used? Because SDT refers to a method of compiler implementation where the source program translate is completely driven by the parser. Your source program is completely driven by the parser. So, for every symbol of grammar, it generates syntax directed translation. So, syntax directed translation SDT refers to a method of compiler implementation while the source language translation is completely driven by the parser. A common method of syntax directed translation is translating a string into a sequence of actions by attaching one such action to each rule of a grammar. Syntax directed definition SDD is a context free grammar together with attributes and rules. You have already know how to draw a syntax tree for given regular expression. Here we represented annotated parse tree. Then what is annotated parse tree? Annotated parse tree represents a tree with attributes and its values. So attributes are associated with grammar symbols and rules are associated with productions. Types of attributes. Attributes may be of 2 types: synthesized attributes and inherited attributes. In synthesized attribute, the attribute of the non-terminal on the left hand side of a production. While synthesized attributes represent information that is being passed up the parse tree, the attributes can take value from its children, variables in the right hand side of the production. In synthesized attribute, values can taken by from its children. For example, there is a one grammar like A produced BC is a production of any grammar. Then A's attributes is dependent on B's attributes or C's attributes, then it will be synthesized attribute. Inherited attributes. An attribute of a non-terminal on the right hand side of a production is called an inherited attribute. The attribute can take value either from its parent or from its siblings. In synthesized attributes, it takes it's from children. So here top down parsing method and bottom up parsing method. From top down parsing method, it calculates from root to leaf, top to bottom, and in bottom up parsing method, it calculates from leaf to root. So for example, let's say A gives BC is a production of a grammar and B's attribute is dependent on A's attributes or C's attributes, then it will be inherited attributes. Synthesized attribute versus inherited attributes. So in synthesized attribute, value of synthesized attribute at a node can be computed from the value of attribute at the children of that node in the parse tree, while in inherited attribute, values of the inherited attribute at a node can be computed from the value of attribute at the parent and or siblings of the node. While in synthesized attribute, pass the information from bottom to top in the parse tree because it takes value from its children. So it performs from bottom to top. While in inherited attribute, pass the information from top to bottom in the parse tree or from left sibling to right sibling. So this is the difference between synthesized attribute and inherited attribute. Sometimes in your exam questions are asked like differentiate synthesized attribute and inherited attribute or synthesized attribute versus inherited attribute. So what is synthesized attribute? Explain with example or write a syntax directed definition for desk calculator. So value of synthesized attribute at a node can be computed from the value of attributes at the children of that node in the parse tree. For any simple desk calculator, first you have to perform basic functions. In simple desk calculator, you have to perform either addition or multiplication or sometimes parenthesis may given. So first you have to write production like L gives E and E gives E1 plus T or E gives E plus T, E gives T, T gives T1 star F, T gives F, F gives opening bracket E closing bracket and F gives digit. You can write any of production at this side. According to this production, write down the semantic rules. Here I can use syntax directed definition for simple desk calculator. So production will be like this: addition, multiplication, parenthesis. You can also use division, subtraction. So L gives En. So here in semantic rules you have to write its attribute and value So L dot value is equal to E dot value. Here it represents its value. E gives E1 plus T, then E dot value is equal to E1 dot value plus T dot value. In any syntax directed definition, first you have to translate your production into semantic rules. E gives T, then E dot value equal to T dot value. T gives T1 star F, T dot value is equal to T1 dot value into F dot value. T gives F, T dot value is equal to F dot value. F gives opening bracket E closing bracket, then F dot value is equal to E dot value. F gives digit, then F dot value is equal to digit dot lax value. It means your any number. Now let's see the example using for this simple desk calculator. In our calculator we used addition sign and multiplication sign. So for consider any input string like 3 into 5 plus 4, and this one is your n. So your input will be 3 into 5 plus 4 n. Digit may vary. So here draw annotated parse tree. Annotated parse tree is nothing but it's a parse tree with associated with its attribute and value. In your simple parse tree you can directly write its value or identifier, while in annotated parse tree its value and attributes both are associated with productions. So draw the annotated parse tree for 3 into 5 plus 4n according to this simple desk calculator. In syntax directed definition, it calculates value from its children. So draw the tree from bottom to top. First 3 into 5 plus 4n. First one is 3. So 3 is your lax value. Digit dot lax value. Digit dot lax value is equal to 3. So here you can write digit dot lax value is equal to 3. This product is come from the F gives digit. So from digit dot lax value you can find your F dot value. So F dot value is equal to 3. From F you can derive F from T. T gives F. So F dot value is assigned to T dot value. So T dot value is equal to 3. Next is input symbol star, then 5. So digit dot lax value is equal to 5. F gives digit. So F dot value is equal to 5. Here T dot value into F dot value. So you have any product like T dot value into F dot value? Yes, T gives T1 star F. So T1 dot value into F dot value, this will stored in T dot value. So t dot value is equal to 3 into f dot value is equal to 5. T gives t1 into f. So value of t1 into value into f dot value is stored in t dot value. So t dot value is equal to 15. 3 into 5, answer is 15. So now value of t dot value is equal to 15. T is derived from E. E gives T. So T dot value is stored in E dot value. So here I can write E dot value is equal to 15 because I can reach up to 3 into 5 plus 4 and form. Next is plus sign. Then 4. 4 is your lakhs value. So digit dot lakhs value is equal to 4. F gives digit. So f dot value is equal to 4. T gives f. So t dot value is equal to 4. Now you have a product like E plus T. E dot value is equal to 15 plus T dot value is equal to 4. Have you any product like E plus T? Yes, E gives E1 plus T. So E1 dot value plus T dot value is stored in E dot value. So 15 plus 4, which is 19, and stored in E dot value. So E dot value is equal to 19. L gives En. So L gives En. The value of E dot value is stored in this non-terminal. So E dot value is stored in L dot value. So your final answer is 19, which is stored in L dot value. So for any syntax tree, 3 into 5 plus 4, multiplication and addition, the priority of multiplication is higher than addition. So first perform 3 into 5, which is 15, plus 4, which is 19. So your final answer is 19, which is stored in L dot value. So this represents the annotated parse tree for 3 into 5 plus 4n. 3 into 5 plus 4n is just the example. If in your exam give any another input, then use that number. Otherwise you can use any number for annotated parse tree. So this is your syntax directed definition. Next one is inherited attributes. In inherited attribute, values are calculated from either parent or sibling of that node. So it is from top to bottom. Here product T gives F T dash. So inherited attribute, which is denoted by INH, inherited attribute, and synthesized attribute, which is denoted by SYN. So T dash dot inherited attribute is equal to F dot value and T dot value equal to T dash dot synthesized attribute. The production T dash gives star F T1 dash. So T1 dash dot inherited attribute is equal to T dash dot inherited attribute into F dot value, and T dash dot synthesized attribute equal to T1 dash dot synthesized attributes. If values are calculated from its children, then its synthesized attribute, or values are calculated from its siblings or its parent, then it's a inherited attribute. T dash gives epsilon, then T dash dot synthesized equal to T1 dash dot inherited, and F gives digit, F dot value is equal to digit dot lax value. So in inherited attribute, draw the parse tree for 3 into 5. Annotated parse tree for 3 into 5. So T dot value gives F dot value and T dash dot inherited value. 3 T gives F T dash. T gives F T dash. F gives digit. So F gives digit. Here digit dot lax value is equal to 3. So F dot value is equal to 3. T dash dot inherited attribute, which is come from its left sibling, which is 3, and T dash dot synthesized attribute, which is 15, because 3 into 5, which is 15, it's come from its children, so it's a synthesized attribute, and this will come from its siblings, so it's a inherited attribute. Your digit dot lax value is equal to 5. F gives digit, so F dot value equal to 5. 3 into 5, so T dash dot synthesized attribute is equal to 15. At this place, that is T dash gives epsilon. So T dash gives epsilon. In synthesized attribute, it's a 15, and in inherited attribute 3 into 5, it's a 15. So inherited attribute 15 passed from T dot value. So T dot value is equal to 15. In inherited attributes, it calculates from its parents or its siblings, while in synthesized attributes, values are calculated from its children. So in synthesized attribute, it performs bottom up parsing, while in inherited attributes, it performs top down parsing. Another is L attribute. So what is L attributed definitions? So the syntax directed definition in which the edges of dependency graph for the attributes in production body can go from left to right and not from right to left is called L attributed definition. In any grammar, dependency graph for the attributes can go from left to right, then it is denoted by L attributed definition. So what is dependency graph? The directed graph that represent the interdependencies between synthesized and inherited attribute at nodes in the parse tree is called the dependency graph. For the rule A gives BC, capital A gives capital BC, then the semantic action is given by capital A dot small a is equal to function of capital B dot small b, comma, capital C dot small c. Then synthesized attribute A dot A depends on attributes B dot B and C dot C. So the synthesized and inherited attributes in the parse tree, its interdependency is represented by dependency graph. So, attributes of L-attributed definitions may either be synthesized or inherited. If the attributes are inherited, it must be computed from inherited attribute associated with production head, because your inherited attributes are calculated from its siblings or its parents, either by inherited or synthesized attribute associated with the production located to the left of the attribute which is being computed, because L-attributed definitions, it can go from left to right, not from right to left. Either by inherited or synthesized attribute associated with the attribute under consideration in such a way that no cycles can be formed by it dependency graph. So this is your L-attributed definitions. Syntax directed translation mechanism. Sometimes various programming or constructs like declarative statement, any assignment statement, arrays, Boolean expression, switch case, control statement, procedure call. So first you have to write down 3 address code for this type of statement. Declarative statement means S gives D. It means your offset is 0. T gives integer. It means T dot type equal to integer, and integer occupies 4 bytes. Then T dot width equal to 4. If T gives real, then T dot type is equal to real and T dot width equal to 8. So thus any declarative statements are used, then first translate into syntax directed translation mechanism. Thus write production rules for given statements. First convert any statement into 3 address code. For example, there is any switch case like begin case C1, then statement S1, case C2, then statement S2 up to case Cn-1, then statement n-1, default statement of n, and switch case end. At that time code to evaluate first L1, then code for statement 1, then go to next. L2 code for S2, then go to next. Up to Ln-1, then code for statement n-1 and next. So thus write down syntax directed translation for any declarative statement, array, Boolean expression, any control statement, etc. So first convert your grammars into syntax directed translation, then draw annotated parse tree. So in your GTU exam, questions may be asked like synthesized attribute versus inherited attribute. What is synthesized attribute? Explain with example, or write a code for simple desk calculator using SDD. What is inherited attribute? Explain with example like this. So this is your unit number 5, intermediate code generation. Thank you.